Well, hello, everybody. Welcome. My name's Philip Brown. This is part two of these kind of cool, well, they're kind of like, to me, they're puzzles. They're algebra puzzles written with exponents. We have to take 2 to the power of x plus 3 plus 8, and we have to rearrange it so it's a times the quantity of 2 to the power of x plus 1. So I know that sometimes math like this can make us feel pretty rough, but if you look at it like it's a puzzle, I think it's a pretty cool thing to do. So if you think you got it, you want to give it a shot, go ahead and pause the video, write your answer in the comment, because we're going to start going over this thing right here. So here's how we're going to tackle this. We're going to first explore some of the stuff that's really at play, some of the properties of algebra and exponents in particular that make this look a little confusing. And we're going to dig into that, and then we're going to talk about some tips about how you can approach these problems so you feel like you're on track, because nobody likes to try a whole bunch of math and not get the answer. It feels like they've wasted their time. So we're going to talk about how you can stay on track and kind of monitor yourself in this kind of a problem. Then I'm going to share some problems with you, 2 practice problems, a challenge problem. Hey, all of this stuff is linked in the timestamps in the description, so go ahead and check those out if you want to move around. So let's get into what's at play right here. Now, this is pretty simple. It's pretty straightforward, but it's a variation of this kind of thing that actually gets a little tricky. So, of course, here we have a power raised to a power. It's actually a group, right? So we have to multiply the exponent for 3, which is 1, and the exponent for the x, which is 4, both by 3, whereas over here, bases is the same. You add the exponent, so the 3 is not the same base, so its exponent doesn't change when we're multiplying. The exponent for the 3 only changes when you raise it to another power. So the 2 rules we're talking about right here is when you multiply the bases, you add the exponents, or raising a power to a power. So the power and the product rule. Those are the 2 we're talking about. Not too complicated there, but what if we give it a little bit of a twist? This is kind of what's going to come up in exploring this problem right here. So check this out. If we wanted to multiply this thing on the left over here, this is what we'd get. Now here's where that comes from, right? The 12x plus 3, that comes from distributing this, and the 3 for this exponent comes from this one right here, because both of those exponents have to be multiplied by 3. So when you multiply 3 times 4x minus 1, you get 12x plus 3. So one key thing to keep in mind is that if you raise a power to another power, the bases don't matter. The exponents are going to change regardless of the base. However, if you're multiplying, not using exponents, not raising a power to a power, then the bases absolutely matter. The only thing that changes is the thing with the same base. So here, this 3 is not x, so its base is different, so its exponent is not going to change. And here we're going to add, right? So this one would become 3 times x to the power of 4x plus 4. All right, so that's what's at play here. So let's go ahead and dig into this, and then I'm going to share with you a tip to help you know if you're staying on track, okay? So one of the things we're going to have to do here is we're going to have to factor this. You see how there's 2 terms inside the parentheses and a number on the outside. Well, we have 2 terms here. We're going to have to end up factoring something out. And so that's going to help us we're going to kind of guide ourselves there. And here's 2, and 8 is a power of 2. So somehow or another, we're going to end up having to factor out a 2. So, man, let's see. Check this out. Help us understand how that works. Most of the time, what happens is we think about math in a certain direction. So you're given a problem like x to the 4th times x to the 5th, and you have to add those. You get x to the 9th, right? What about when you go the other direction? That's kind of like what factoring is like. If you had x to the 9th, could you do it backwards, right? So, for example, if we had 2 to the power of x plus 3, like we have here, well, if we kind of went backwards, that would be 2 to the x times 2 to the 3. So we're going to rewrite that there as 2 to the x times 2 to the 3. And the reason I'm going to do that is because 8 is also 2 to the 3. So I'm going to rewrite 8 as 2 to the power of 3, right? And now we have a common factor. We have 2 terms, right? Terms are separated by plus or minus. So we have a term over here, 2 to the power of x times 2 to the power of 3. We have another one over here, 2 to the power of 3. So we can factor out that 2 to the power of 3, and this is what we have. Look at that. 2 to the power of 3 times 2 to the x plus 1. Looks to me as though a is 2 to the power of 3. I think that's pretty cool. Not entirely obvious, not super difficult, but You kind of have to think about some stuff in a different way. So I think that's a pretty cool thing right there. All right, so now here's I'm going to share 2 practice problems with you, and then one that's a little bit trickier. So go ahead and pause the video. You can write these down, try them out at your leisure. When you get the answer, hey, give me a comment. Let me know what you think it is, and how you think these kinds of problems are. Do you like them? I think they're pretty cool, but what do you think? Now, the challenge problem, it's a little bit uglier. Yeah, go ahead and give that one a shot too. And hey, if you like this kind of content, do what all the cool kids are doing. Like, subscribe, comment, share. Let me know how it's going. If you're a math teacher, check out my Substack. I have a weekly math problem that's just for fun. I use it in my classroom. I'm surprised how many students just love doing it. And the number is growing every single week. I've got all kinds of resources for teachers. Make your life easier. Check out my website on teachingmath.org. And I have a bunch of stuff on Teachers Pay Teachers as well. But in the meantime, I really liked this problem. I hope you did too. Hope I see you soon, and have a great day.